Unit circle. You will study the unit circle either next year in advanced algebra or in pre-calculus, and it's kind of a big deal, but we're just going to dabble a little bit into the unit circle. And the unit circle does things like this. It asks you what is the sine of 30. So if you bust out your calculators, which you'll need, and plug in the sine of 30, you get, say again? 0.5, also known as 1/2. The question is, could we do that without a calculator? How? Any ideas? Yes, but that's going down a path that we're not ready for. Yeah, good. Unit circle. You would use a circle to find that. Yeah, it's good. Yeah, no, not right now. What do you got?
You choose something with pi.
No. I don't think you could. Any other ideas? Want some help?
Yeah.
How about that? How would the general form of a 30, 60, 90 triangle help me find the sine of 30 degrees? Go ahead.
Well, it has a 30-degree angle in it.
It does, that's a good start. It's got a 30-degree angle right over here. So? Go ahead.
The sine is opposite over hypotenuse, so then it would be a over 2a. And then
And what's a over 2a equal to?
1/2.
1/2, right. The a's cancel, and therefore we get 1/2. Is that better? No, it's horrible. But we'll go with it. Does that make sense?
Yeah.
Okay, beautiful. Then what's the cosine of 30? Without your calculator, we'll do the calculator in a second. Now you got me going. It's like a yawn. You see somebody else yawn and you yawn. You see somebody else sneeze, now you sneeze. What do you got?
The square root of 3 over 2.
Why?
Because the cos is
I'm sorry, the what?
the cosine
Yeah, yeah,
is
cosine. Yeah.
a square root of 3 over 2a, because a square root of 3 is the adjacent leg over the hypotenuse, which is 2a, and then the a's cancel out, so then it's square root of 3 over 2.
Beautiful. How about the cosine of 60? Ethan,
A over 2a.
which is
1/2.
1/2. All right, let's change it up a little bit then. We just did that guy. How about the tangent of 45? Liam?
Okay, tangent. I think it would be a over a root 3. No?
Want some help?
Sure. Okay, a over a.
Which is
1.
1. On your calculator, punch in the tangent of 45 degrees. What do you get? 1. Punch in the tangent, no, what do we do? Cosine of 30, which Katina had the square root of 3 over 2, but the calculator tells us 86, blah, 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 blah. So I'm guessing that if you do the square root of 3 divided by 2, you would get the same answer, and you do. So what are you going to get out of this? You should be able to find the sine, cosine, and tangent of the 3 big angles, a 30, a 60, and a 45. Notice we're not doing anything with the 90-degree angle. Remember, we stay away from the 90-degree angle because weird things happen. Okay. We good with this? Everything relates back to the general form. So remember, the a's will cancel when you set up your general form of any of these sides, opposite over adjacent, adjacent over hypotenuse, etc., etc. The a's will cancel. So it works for any triangle. Doesn't matter how big or small it is. Okay. Let's move on to the exciting stuff. That's the same triangle we worked with yesterday, where we did the calculations and did some other stuff with it. We asked why that's a right triangle, blah, blah, blah. The one thing we didn't talk about, though, is how big is angle P? I'd like to be able to solve for the measure of angle P. And let's suppose I find the measure of angle P. How can I find angle A then? Somebody. Yeah.
You can add E and P together and then subtract that from what A.
Good. Triangle sum would allow us to find A. So if we can do this once, we can easily do it once to find angle P. We can easily find angle A and don't have to do the calculations. It's a fairly simple process if you understand two simple things, and that is how to set up your trig equations and how to get rid of the trig equations. And we're going to use something like it says here, what's called an inverse function. What's an inverse function do? What's the inverse function of squaring? Square rooting. What's the inverse function of addition? Subtraction. Inverse function of multiplication? Division. So why are those inverse functions, what do they do? The opposites, right? They cancel each other out. So we're going to look at an inverse function. So if you look at your calculators, above the sine, cosine, and tangent buttons, there's these things. That's not the reciprocal. Remember, raising something to negative first. No. That's the inverse function. That's the inverse function of sine, inverse function of cosine, inverse function of tangent. And when I solved this problem, I skipped an important step which I think might be helpful. So I'm going to go through and do it again. This equation came from what we did yesterday. Okay, if you remember the triangle on the previous slide, the angle A, the opposite side is 4, the hypotenuse is 5. The question is, how did I go from here to here? And so I'll show you that step. Sine of A is equal to 4/5. I intentionally left a gap here. You'll see why in a second. I want to figure out what angle A is. In other words, I want angle A by itself. So I need to get rid of the sine function. To get rid of the sine function, I take the inverse sine function. Basic rule of algebra, whatever you do to one side of an equation, you have to do to the other side of the equation. What's the left-hand side become? Gesundheit. Just A, because these two undo each other. Good. How do I find this? Calculator, do it. 2 decimal places, please. Be careful with your parentheses also. I believe does it put in a parentheses automatically?
Yeah.
Yeah, so you gotta be sure to close parentheses. Otherwise, it's gonna take the inverse sine of 4 and then divide the answer by 5.
I got 53.13.
Can somebody confirm? 53.13?
Yes.
Now, to find the other angle, I don't remember if it was B or C or whatever it was. We could go and do this again. We could set up another trig equation, do an inverse trig, but we don't have to. We can just take this, and we know that 90 plus 53.13 plus that other angle, I think it's B, we'll go with B, is going to equal 180. Or these two angles add up to 90. Because the two angles are complementary, all three of the angles add up to 180. So that makes B 37.87? 36.87. Is that right? Okay, good. That allows us to do something now called solving a triangle, which you can pretty much, can I erase this by the way, are we good?
Yeah.
Okay. You can pretty much figure out what that means. There's 3 chunks of information. If I've solved the triangle, that means when I'm done, I know all 6 things from that triangle. So in this particular example, first of all, what's the name of my triangle? ABC, good. What chunks of information am I missing? Jake,
One of the sides and 2 angles.
which side?
The leg, the other leg,
What's it called?
the like small C.
Small c, good. And what else am I missing?
The two other angles.
Which are called
Big A, big B.
angle A and angle B. So you might want to start with a picture. What vertex is this? C. What vertex is this? Does it have to be A?
No.
Could be B, but we'll make it A. This one's B. How long is this side? C, we don't know. How long is this side? 18? Gesundheit. This side? 13. Okay. How do I do it? Where do you want to start?
Couldn't you just do Pythagorean theorem?
I like it. Give me the setup.
18 squared plus 13 squared equals x. No, c squared.
Good. Solve for C, but leave it in exact form as a square root, because we want to use exact answers to calculate. Katie, what do you got? Square root of?
I got C squared is 493.
Good, so C is the square root of 493. Do you have an approximate value for me also? Or did you not take it that far?
I haven't been in there.
What do you got, Ellie?
22.2.
Can somebody confirm?
Yes.
I assume she knew how to take the square root of 493, but just to make sure. Am I happy about that answer?
No.
No? Why not?
Seems like it should be a whole number.
Why? Because everything in life is a whole number? I'm actually happy about that answer. What makes me happy about that answer? Good, it's the biggest one, it's gotta be the hypotenuse. So before we start the calculations for A and B, which one will be bigger, A or angle B? Why?
Or no, angle B,
Why?
because it's got a shorter side.
Good. Yeah. Angle B will be the bigger angle because it's opposite the bigger side, or A will be smaller because it's opposite the smaller side. Okay, since we started with you want to solve for A or B, Katie? There's no wrong answer, by the way, it's just personal preference. A, okay. And which of the three trig functions do you want to use, sine, cosine, or tangent? Again, no wrong answer. Any particular reason you chose sine? Okay. You did say A, right?
Yeah.
Okay, so the sine of A is equal to what?
13 over 18.
Mm-mm.
Or 13 over 22.2.
Perfect. 13 over, I'm actually going to use the square root of 493 because I want my answer to be as accurate as possible. Unless you stored that information. Good. How are we doing so far? Did I lose anybody? Now, when I asked her those questions, the answers really didn't matter. If she wanted to do angle B first, we could do angle B. If she wanted to use the cosine, we could use the cosine. We could use the tangent. Because we know all three sides of the triangle, we can use whichever ones we want. Now, how do I get A by itself? Look at. No, you can't divide by sign. It's not a quantity like a number. You have to, it's a function. You can't divide by functions, but you can undo functions. So how do I undo the sign? Good. And if I do that to one side, I have to do it to the other side. The inverse sine and the sine undo themselves. Plug and chug into your calculator.
35.84.
35.84, confirm?
Yeah.
They like it. 35.84 degrees. Does that make sense with what we already talked about? Yeah. A has to be the smallest angle. It's less than 45, so we're good to go. And therefore, angle B would be 90 minus that, which I believe would be 54, nope, 54.16.
Yes.
Nice. I'm a professional. Question?
Can you use tangent or cosine? You don't have to use sine for.
You can use whichever one you want,
It's
as long as you set it up correctly.
Yeah.
Yeah, that's the only stipulation.
Oh, for any angle, you can use any of the three.
If you know all three sides, yeah, you can use whichever one you want.
Oh, but if you only know like one side, you have to use the specific one.
Yeah, you gotta use the one that matches up with the ratio of the sides that you have. I know all three sides, I know all three angles, I've solved the triangle. Okay, we good? It's exactly what we did yesterday. You set up the equation, now we just throw in that extra twist where you do the inverse function to get rid of the trig thing. How can we make it more interesting? You can't, this sucks. No ideas? How about a word problem? Okay, now, first thing I'd like you to do is sketch the situation, because if your picture's wrong, the whole problem's going to be wrong. And think about a real-world application. If I go outside to measure the flagpole, there are certain things I'm going to do and not do. That's the only hint I'm going to give you. So draw a picture. Once we get everybody's picture set, then we'll finish the calculation. And you need all the information in the problem. I didn't give you any red herrings. Do you know what a red herring is?
Yes.
Yes. No, red herring is a chunk of information that you don't really use. It's like a way to trick you. Did you buy that from the dealer there? She was pushing her wares in my classroom. I didn't even get a cut of that. Usually I'd like 10%, but what'd you pay for that? So she owes me $9. I did that in my head, 10% per dollar. When am I getting my money?
Buy some chocolate.
Oh, that wouldn't give me money. I would lose money. House has got prospered too, right? You got for picture? You ain't got a picture. What do you got for picture? Not a bad picture. What do you got for picture? You ain't got a picture. That's a great flag. Good flagpole too. Okay. Interesting. All right. So, let me draw what I'm seeing from a number of people. America. 43, 44, 45, 46, 47, 48, 49, 50. Okay. We're assuming the flagpole is perpendicular to the ground. I think that's a pretty safe assumption. Flagpole's perpendicular, buildings are perpendicular, et cetera, et cetera. Let's see, 37.5x. What's wrong with that picture? Yeah.
The person's eye needs to be 5.5 feet off.
Where is the person's eye right now?
On the ground.
On the ground. So someone's laying in circle drive with their eyeball in the grass or on the concrete.
Yeah.
That would be quite uncomfortable. So that's not going to work. How do we change it, Liam?
We would raise the corner about 5.5 feet.
not sure if I follow what you're saying.
And if you draw a stick figure at the bottom right, then say his measurement is 5.5 feet. Then just draw a line segment from his eye, where his eye would be to the top. Of the
It's a he?
He, yeah.
He. He's kind of thin. From his eye?
Yeah. Up to the flagpole.
Okay, now what?
So the base leg, the longer leg would be 100 feet.
This?
Yeah.
Okay, hundo.
And then there would be an angle between the person and the ground that would be 37.5.
Between the person and the ground. I don't know if I follow that.
Between the
Do they have one leg shorter than the other?
Yeah.
Right. So they have one leg shorter than the other? You sure it's not a woman? Named Eileen? One leg shorter than the other, Eileen? Yeah. Wow, it loses a lot when I have to explain that joke. So we're staying with a guy,
Yeah.
and where's the angle?
The angle starts at his eye
And goes,
to the top of the flagpole. Oh wait, no. The angle starts at his eye, goes to the leg with 100 feet.
so, I'm
Like the leg
confused.
of the triangle.
Here?
Yeah.
Not quite. Ellie,
So does like the bottom like start at his eye,
start at his eye,
like the leg, like the bottom?
the bottom starts at his eye and goes up,
No, it goes like straight.
goes straight, like this?
Yeah.
Is that what you meant?
Yeah.
Okay, how long is this?
I don't know. 5 feet.
5.5 feet. That actually says 5.5. I wrote it cryptically. Liam, where's the angle now?
I think it's at the top. I'm not sure actually. Oh, it would be right there.
Yeah.
Yeah.
Whoops, 5. So none of this rectangle at the bottom matters until the very end when we want to find our answer. So we're actually solving for this distance. So that's not really the height of the flagpole. That's the height from the eyeball straight across up to the top of the flagpole. If we call this x, then our final answer is going to be x plus 5.5. That's a little easier way to do it than to stick your eyeball down on the ground. This is still 100 feet because it's a rectangle there at the bottom. What function would we use? Sine, cosine, or tangent? Tangent, because we are looking for the opposite side and we have the adjacent side. Tangent of 37.5 is equal to x over 100. Will the height of the flagpole be bigger or smaller than 100? Smaller. Good. And we're not going to do the rest of the problem. I just wanted to set it up that way. Because this weirdness of your eye off the ground pops up in problems. Not every problem. Some problems are just written where you put your eyeball down on the ground or the angle is measured down on the ground. But in this situation, you have to consider how high above the ground the eyeball is. Okay, we good? You get 82.2 feet, by the way. We'll skip that one, and I think we're done for the day. Okay, so you all remember Miss Cusack, right? Cusick. I keep saying it wrong. Cusick.